Here's a look at the quadcopters we'll be using for the next few lab assignments. These are known as Parrot Mambo mini drones, and you can buy them on Amazon for $50 to $100. What's most important is that Parrot partnered with MathWorks a few years back to provide an open source MATLAB Simulink flight controller package for these little mini drones. You can find more information on that flight controller package in the link in the video description. We've made some customizations to that flight controller for the purpose of these lab experiments, but before I talk about that, let me point out some of the parts of the quadcopter, and for this we've disassembled one so you can see the guts. The vehicle, of course, has the four motors, which you can see here. It also has an IMU, an inertial measurement unit, with a 3-axis accelerometer and 3-axis gyroscope that it uses to obtain an estimation of its attitude. To get a sense of its altitude, there is a small pressure sensor similar to the 2004 water rocket altimeters located here, as well as a downward pointing sonar located here. The vehicle fuses these sensor readings together to obtain a better estimate of its altitude than either one sensor could provide. There's also an optical flow camera located here. The vehicle uses information on how the image changes from frame to frame to get an idea of its horizontal location in the environment. This first experiment, we are going to observe how the vehicle performs without any feedback from its onboard sensors. To do this, the controller will take off and achieve a hover about 1 meter off the floor using the default control gains. After approximately 5 seconds, we will hold the motor signal values to the value that they had right before the cutoff time, thus disabling the feedback controller. Keep in mind we aren't turning the motors off, as that would obviously cause the vehicle to immediately crash, nor are we modifying the control gains in any way. We are only holding the previous value that was sent to the motor controller. This is similar to achieving steady flight in a fixed-wing vehicle, then blindfolding the pilot and asking him or her to not move the control sticks from where they were before. In the accompanying video and datasets, you can observe the response of the quadcopter.